2D problems. Now, last lesson, we kind of finished off with a question that was very similar to this, with the triangle where we had to find the area. So we had to find the perpendicular height using Pythagoras' theorem, and then we had to then apply it to the rule. So that's what we're kind of looking at. Most of the time, if you don't have a diagram, construct a diagram first. That will always help. But for the most time, you'll be given diagrams. So this one here, we have a nice trapezium. And it's asking us, first of all, it's kind of holding our hand a little bit. It's asking us to draw a right-angled triangle to help find the unknown length. Now, you can see the unknown length there is by the question mark. So what we're looking at here is constructing a vertical line straight down through there where we have this nice right-angled triangle. Now, if I construct it out here, which sometimes that makes it a little bit easier when you're trying to do these questions, we can see the hypotenuse here is 28 meters. This is the kind of question mark or the height there, which means we should have the other length. Now, of course, if this bit here is 20 meters there and the whole thing is 37, then that last part must be 17. So this bit here is 17 meters. So that's the first part. The second part then says to hence or otherwise find the missing length to 2 decimal places. So let's now solve this diagram. Let's put this as a H. Okay, you can put it as an X. We'll leave it as an X. We'll leave it as an X. So something like this, x squared plus 17 squared equals 28 squared. So we've applied it to Pythagoras' theorem. Yes, some of you may have automatically done the 28 squared minus 17 squared. That's the next step. And so certainly that is absolutely a-okay to do that as your first line of working, but I want to see at least one of them, if not both. Okay. Once I get that, you technically speaking can write x equals. Now, I've got to say, I, as a teacher, will always write it out. So if it's good enough for me, realistically, it should be good enough for you. A lot of boys and girls, for that matter, like to take shortcuts. Okay, and when we take shortcuts, we tend to make mistakes. So I try and refrain from doing that. So 495 is what x squared is equal to. And the reason I like seeing that there is because I can clearly see that that length can't be 495. I have to square root my answer. So I'm going to square root my answer there. And I get this answer of 22.24859 ... Now it says to 2dp, so x equals 22.25 meters, and that's my answer. Again, they're the lines that I want to see, at least one of the first two lines plus the answer. However, I think technically you should write them all of them because it's going to help you get those answers correct. So there are some easier questions. They do get more challenging. I'm going to show you only two today. That's the first one. It's an easy one. You'll be doing the ones all between that, so between 4 and 9 I think I've set you for today. This is question 10 I thought I'll do together. Now, reasonably hard. It's a bit hard to see in this diagram here. I'm going to go over with a black pen. I'm just going to make this a little bit darker so you can see. That's where the kind of the post is. So we've got a 100-meter radio mast that's supported by these 6 cables in 2 sets of 3. So this is the first set of 3. There's one there, and then we come out 2 there. Then we have another set of 3, 1, 2, and 3. And it's kind of like, it's almost a three-dimensional sort of shape. Okay, because these all are going to go out to different points. They're anchored to the ground at an equal distance from the mast. So this distance from all of them, okay, if that's my right angle triangle, are all the same length. The top set of the 3 cables is attached to a point 20 meters below. Okay, so up here, okay, a bit hard to see there, isn't it? I might do it in black, is 20 meters below. Okay, so at least that we know that part is 20. Each cable in the lower set of the 3 cables is 60 meters long. So there we go, that's 60 meters long there, and is attached at a height of 30 meters. Well, straight away I can start to see, and I might just try and shade it here, this nice little right angle triangle. We've got the 60, we've got the 30, we simply don't have this length on the bottom there. So technically speaking, this is what I've got, right? I've got my X here, my 30 here, and my 60 here. So let's use Pythagoras' theorem to find out what X is equal to. Remembering that the distance from all of those wires is the same from the center of that mast. That's what we're trying to find at the moment. So X squared, actually we'll say, instead of saying X equals, we're going to say X squared plus 30 squared is equal to 60 squared. So again, I'm just applying it to Pythagoras' theorem. I'm now saying x squared equals 60 squared minus 30 squared. Once again, I'm going to say, if you want to do that as your first piece of working, most welcome to. I'm now going to type in my calculator. I'm going to type in 60 squared. I'm going to do minus the 30 squared. Okay. And I come up with x squared equals 2700. I'm going to find out what x is equal to, knowing that it must be positive. So square root of 2700 equals 51.96152.423 ... Again, important that this is a measurement question. We want to keep that number because we're going to use that for the rest of our working. We don't want to round up early. Even though it says 2 decimal places, we round at the end. All right, so what have we actually found? We found the distance away from the center of the mast to each of those kind of chords. Now, the question then says, if all the cables have to be replaced, find the total length of the cable required. So I need to find all those cable lengths. Now, we already know the bottom three. The bottom three are each 60 meters in length, right? So we already know that. But we don't know the length of the top one. So if I redraw out the top sort of diagram, right? We now know the distance from the center of the mast to the horizontal length. We now know that's 51.9614 ... or the square root of 2700 if you want to have the whole number. We know that part. We need to figure out what the distance is the whole way along. Now, obviously, the top part is 20 meters and the whole thing is 100. So the actual length of this is going to be 80 meters. So you can see how we're using Pythagoras' theorem to go and find, let's call it h, that length there of the big wires. So in this case, h squared equals 80 squared plus, now I'm going to use square root of 2700 squared. Again, you could type in 51.96152423 squared, okay? But ultimately, that's what we're looking at. We're going to jump onto our calculator now. We've already got the 51.96 in there, so I'm going to type in here 80 squared on my calculator. I'm going to say plus answer squared, because that will do that automatically, equals, and I get this 9100. I'm going to square root my answer. So you can see where this is quite a tough question, guys. And I get 95.3939 ... So that's the length of the big wires. So what we've got is the small wires, 3 of them at 60 meters. I've now got this 95.3939 3 times. So let's actually say 3 lots of that. So we're going to simply times that answer that's in our calculator by 3. Now again, I'm using the calculator version because that's the exact number. I don't want to round early, and I press times 3 and I get this 286.1817 ... I'm going to add on, what 360s are 180, is that right? I'm going to add that all together. I'm going to press plus 180. And finally, when I get my answer, the length is going to be 466.1817604. Now I can round to the 2 decimal places. Length equals 466.18, and that's meters. And that is my final answer. Can breathe, okay? It's a lot going on in that question. Number one, you need to have a clear diagram. If your diagram's not clear, and this one certainly wasn't, draw some other triangles out that are going to help you. Find some stuff that you can do. Like if you're not sure, just try and find some sort of a right angle triangle using Pythagoras. And then try and apply it to the question. See what they've asked for. Make sure the rounding only occurs at the end of the question. Write all your decimals out if you're not 100% sure as well, or use the answer button in your calculator. That's a really nasty question, I think, for Pythagoras, but it's a good question for us to look at. I hope that made a bit of sense. Have a crack. I think I set you there, I'm pretty sure, questions 4 to 9. So have a go at some of these questions. Draw diagrams where needed. Any problems, drop me a message via Canvas. Otherwise, I'll see you for our next lesson where we are starting to move into trigonometry. Exciting times ahead. Have a wonderful day.